All right, so what about the platform? First of all, what is the platform for web applications? Basically, that's everything but the web server and everything below it. Okay, so the platform that comprises the functionality used by web applications uh, is normally something that the application itself is built by and with. Okay, so that's programming languages, frameworks, libraries, shared built libraries, and so on, and anything it connects within the same execution domain. Okay, so databases, data exchange protocols, maybe device drivers if it's a really risky web application. Yeah, I would say so. Normally, it's the language, it's the development language that is used to build the application, and some components that are dedicated or shared in the form of a database or data exchange, data connector module, something like that. So that's what the platform is. What can be done against that, and what are the specifics? Let's review. So currently, for programming web applications, it is possible to use virtually any programming language. Okay, so as long as CGI interface is uh, supported by it, I would say, yeah, because every web server just allows you to access your web browser client by CGI, yeah, by passing these parameters in the HTTP requests and pass the responses back. So you can write it in C, definitely you can do that. In C++ or even in assembly language, I guess. It is virtually possible, why not? But um, it is strongly unrecommended. Why? Because the lower level languages are inherently prone to all those memory corruption bugs. Okay, so unless you use some really uh, mature framework that has built all the system calls and system call wrappers and other functions available to the application developer in a way that theoretically excludes the probability of memory corruption. Yeah, so unless you arrange that level of security of the environment, it is not recommended to use the lower level languages at all. So you have to use something that has got over, yeah, that memory corruption problems. And there we can choose from a variety of things, but the most success I would say have those two, Java and .NET. So these are the languages, yeah, that are designed specifically to be at a higher level of abstraction and avoid all that problems that are associated with memory management, with memory access, with buffer control, with garbage collection, with all that things that are like in the lower level languages, reliant upon the developer to arrange manually. Okay, so here everything is built in, and we can expect from Java, for example, that injection vulnerabilities, yeah, they will be there, but buffer overflow is it's rare. Okay, so at the same time, the Java runtime environment itself, yeah, the virtual machine that runs Java code, is prone to many different vulnerabilities, including memory corruption bugs. But the Java, the language itself, is more or less secure, I would say, right now. That causes a lot of problems as well, because when we are talking to software developers and we are telling them, guys, let's go through some bootstrap of application security. Let's have a course, okay? They say, oh, let's skip all that. all that buffer overflow crap, because you know we use Java, we use .NET, we don't use the languages that can be possibly attacked in that manner. Yeah, so the best way to ask them to settle down this little friction, yeah, is just ask them, guys, do you know how to deal with that if uh, if that happens, that you have to. And then if they really know that, yeah, so they went through some kind of training against buffer overflows and other memory corruption bugs, maybe it's possible to skip that chapter. But normally they just don't know. Okay, so they just have chosen a framework of a kind, and they know that it is theoretically resistant to those kind of threats, but that's not enough, because tomorrow they will be told to use another framework, and then everything will be yeah, not that funny. Okay, so it's prevalent. Okay, so Java and .NET is dominating enterprise world, I would say. So the most amount of code that is written for large enterprises, in-house or outsourced, it's in those two. Okay, there are edge cases of using PHP, or very customized flavor of PHP that is in the end anyway is translated to some binary code, right, for higher performance, for example, as in the case of Facebook. Okay, but mostly that is Java or .NET. Yeah, if it's like, I don't know, is it okay to say low end here? So if it's low end, and if it's like generally available to a really to a guy who is just starting his career, or the girl who is just starting the career in the software development, and they want to build up their application, it is most probably the PHP. Yeah, the platform of choice will be PHP, because it's dominating the open source world, and it is really simple to start with, and it has connections to most frameworks and databases, and can implement virtually anything from XPath and XML handling to connection to any database management system. So that's very popular, and that caused a lot of troubles previously, and still continues to create a lot of security considerations, because previously PHP was not a very good tool by itself, but now it's getting more mature, but still there are different cases. Now it's more of a misconfiguration, not the memory bugs, but still exploits for PHP are reported with some rate. Okay, it's not rare to see that on public. JavaScript is a problem in and by itself. Okay, so that's the language that first of all was created within 10 days, literally. That's a really sad story, but its simplicity and its ability to run in different browsers, and now on the server side as well, it caused a tremendous popularity, and now we see this phenomenon of JavaScript running on virtually anything. Okay, so we have to deal with that somehow. The community is going through all this trouble by creating a lot of frameworks. Yeah, let's discuss them a little bit later, but the inherent problems with JavaScript remain. They are planned to be circumvented in the later releases of the language specification, but unfortunately those specifications, they introduce more security considerations than they resolve, I guess. So then we have those two, Python and Ruby. Python is getting more and more popular, and that's a good thing, because yeah, the language is really interesting. It's more or less simple and really easy to get started with, and it's a little bit firm and strict in the same time. So Ruby has multiple frameworks and it's powerful by itself too. However, those two have a really weak point. Yeah, so they are not very good with versioning and dependencies. Yeah, so it even is more convenient now to create a virtual environment with all dependencies installed locally, just in the current directory, for a Python or Ruby application. So yeah, that's ridiculous sometimes, but I hope that will be resolved in Python version 3.6 already. I don't know. So multiple versions of compilers and interpreters and multiple versions of libraries and dependencies causes a lot of trouble in those two realms. So what do you need to know about that on the principle level? So all these programming languages are either scripted or compiled. I would say that neither of them is truly compiled, because yeah, Java and .NET they create assemblies of some sort, but those are more of like bytecode translated for later use memory chunks. Yeah, and Python of course creates the PyC files as well between the runs of the code that is not changed from run to run. Yeah, so that's questionable whether that is a compiled code. So let's assume that everything is more or less scripted here. Okay, so what does that mean? So compiled code resides on the disk in some kind of a binary representation. Okay, so it shouldn't be processed by compiler or interpreter every time it runs. On the other hand, a scripted program is just a text. Okay, so it's compiled to the memory every time it is run. Okay, so what's the difference in terms of security? Changes are quicker in scripted languages, of course, but the speed of development also is much faster. So that causes a lot of trouble because people are just trying to get that to production as fast as possible, and in the end we have a lot of security bugs. So I would say that as a penetration tester you will be faced with different speed of response. Yeah, so Java will be probably much faster than Python and PHP. Okay, so since it's like more binary, less processing, more code in machine readable form, not human readable form. Okay, so who is there to save the day? Okay, since all those languages are quite immature still, except for Java and probably .NET, I would say, there are a lot of reusable code for that. Yeah, so these languages are mostly created to implement the primitives. Okay, to implement the very low level actions that in order to be usable, in order to be useful for web application programming, have to be combined into some larger constructions like classes or libraries or collections of functions, templates, and so on. So some means of automation of development are in the game right now. So that means that a lot of so-called frameworks are created for every language. So there is no chance you will be successful in your development career if you just start typing in Python commands every time. You need to create a web application from scratch. You have to use some existing code. Yeah, and frameworks are there just for that. That's the good thing. Because the more code is reused, the more are chances that someone will find vulnerabilities in these chunks, in these pieces of code, and it will continue its existence with less vulnerabilities. than if it would be than if it was built from scratch every time. Okay, so this is logical, but there is always a but, and in this case it's that the more we develop the frameworks, the more functionality we add, yeah, and it is not really thoroughly tested. If it's open source, that doesn't guarantee that this presumed potential for review by 1,000 of eyes of interested developers actually results in someone just going in and reviewing anything. Yeah, so no matter it's open sourced or closed sourced, it will have large impact. Yeah, so once with a low probability there will be a security bug, it will be almost automatically used to build or rebuild new versions of web applications, and it will be deployed widely throughout the internet. Okay, so checking whether the application you're trying to hack into uses the components, the frameworks that have known vulnerabilities is the reasonable first or second step in the penetration test of web application. Okay, so these are different popular framework you can find currently in use by developers, and I would highlight maybe AngularJS here, because yeah, vulnerabilities in jQuery are reported more or less frequently. However, AngularJS is an example of a framework that is developed by Google. Okay, so Google, when they do something, when they really focus on doing something, they normally do a good job. So, but there is this never-ending cat and mouse game. So there is this new class of attack, for example, AngularJS template injection. So there is you can imagine that as a kind of sandbox. Yeah, every new version of a framework, of the framework, is introducing new controls, yeah, over that sandbox. Yeah, and hackers are starting with each new release. Hackers are starting to get the new ways to get out of that sandbox, and normally they succeed, and then the new version of the framework is released, and so on. So that happens like as we speak. Okay, and it's never ending. So it will always be this arms race between hackers and protectors. Every time you want to break in, you have to start from seeing whether it's possible to hack into underlying platform, into the framework, or find a remote execution bug in the compiler or interpreter. So that all is really a thing to start from, because that will give you more potential overall, because as you remember, underlying layers are explicitly trusted by the higher layers.